Hello. I just wanted to start off by saying thank you to our clients and stakeholders for your interest in this project. My name is Dylan Matheny. We're very excited to talk to you today about this renewable energy system and its potential for success. Our team consists of myself, Trent, Jaelyn, and Grant, and we've enjoyed looking into this business venture. We heard you when you told us that you wanted to be the owner of a renewable energy system but had no idea where to start. So we've come up with this idea for Nevada's first and only wind-powered EV truck stop along I-80 between Reno and Elko. As I'm sure you know, Tesla's Gigafactory is located east of Reno in Story County, where EV components and lithium batteries are made. It's safe to say that EV ownership is growing in this region of the United States, and there's potential for growth for EV delivery fleets as well. According to NREL, in 2024, American companies deployed more than 15,000 medium and heavy-duty EVs, including battery electric semi-trucks, passenger buses, and delivery vans. This project could serve as a prime destination for all travelers from Sacramento, California, all the way to Salt Lake City, Utah. I wanted to briefly touch on the feasibility of this project, as we are aware that you wanted to start out small and get your foot in the door before expanding to a larger commercial-sized or even community-sized project. Wind turbine technology is rapidly evolving. This map shows the predicted mean annual wind speeds at a 30-meter height. Areas with good exposure to prevailing winds and annual average wind speeds around 4 meters per second and greater at a 30-meter height are generally considered to have a suitable wind resource for small wind projects. Small wind turbines are typically installed between 15 and 40 meters high. The location we flew to during the opening sequence is the only utility-scale wind farm in Nevada, located near Ely. It's called the Spring Valley Wind Farm and has a capacity of about 152 megawatts. You can see on this higher resolution NREL wind resource map that there are similarly shaded regions along I-80 when compared to the regions around Ely, meaning that similar performance at up to 100 meters above surface level could be obtained provided proper site selection. Today, we'll talk you through why this project's feasible for a small start and key policies and incentives that can make this a smart investment. This small-scale setup lets you own a revenue-generating asset with low entry barriers, powering EVs while qualifying for incentives to offset costs.
Interconnection standards are basically the laws and technical procedures that tell us how a customer-owned renewable system, such as a small window turbine, can safely and legally connect to the grid. These rules are in place to ensure that the system doesn't harm the grid, doesn't pose safety risks, and meet consistent engineering expectations across the state. In Nevada, these requirements come from a combination of state statutes and utility rules. First, we have NRS 704.771, which defines which renewable systems qualify for interconnection. Then, NRS 704.774 outlines the safety and technical requirements the system must follow. We also have a more detailed set of administrative regulations, NAC 704.330 through 704.347, which break down the processes even further. And finally, Nevada Energy's Rule 15 functions as the utility's official interconnection procedure, covering details like testing, metering, and even approval steps. Together, these form the foundation that governs how a small wind turbine connects to the electric grid in Nevada. Which system qualify? Well, first, the system must use a renewable energy source. This includes wind, solar, hydroelectric, geothermal, and so on. In our case, we're focusing on small wind systems. Second, the system must have a capacity of 1 megawatt or less. That's the upper limit for customer-owned renewable systems under the statute. Anything larger is governed by a different set of rules. Third, the system has to be located on the customer's premises, and it needs to operate in parallel with the utility grid. That means the system and the grid are working together at the same time, allowing energy to flow both ways when appropriate. There are some additional provisions for non-residential wind systems, particularly those on institutional or educational properties, but for most small wind installations at home, ranches, farms, and rural businesses, the standard definition under NRS 704 0.771 applies without any additional restrictions. This makes it fairly straightforward for most small wind clients to qualify. Alright, next let's talk about the technical and safety requirements that apply to every interconnection project. Nevada standards rely heavily on nationally recognized electrical and engineering codes, so a system must meet the National Electrical Code, along with the relevant UL certifications, for example, UL 1741 for inverters, and must also follow IEEE standards for power quality, grid interaction, and equipment performance. The system also needs to include a proper disconnect switch, compliant wiring, and a detailed one-line electrical diagram showing exactly how the system connects to the property and the grid. NV Energy will also evaluate the customer's metering setup to make sure that it supports the net metering or export measurement. All of this must align with the requirements laid out in NV Energy's Rule 15, which I mentioned earlier, which spells out how customer systems must operate when running in parallel with the grid. If the system meets these national and state standards, it significantly increases the likelihood of utility approval. Now I'll walk through the interconnection process step by step. The first step is submitting the interconnection and net metering application to NV Energy. This application includes the equipment specifications, electrical diagrams, and metering details. Next, NV Energy performs a technical review. This would include verifying that the system complies with Rule 15, which mentioned earlier, and it also meets safety standards and also won't negatively impact the local distribution grid. After the review, the utility will either approve it or request modifications, usually related to metering, protection equipment, or wiring clarity. Once approval is granted, the customer or installer can go ahead and install the turbine, along with all the required disconnects, wirings, and metering hardware. After installation, the project must pass a final inspection, usually by the local authority having jurisdiction, and then by NV Energy. If everything meets the standards, the utility issues permission to operate, and also known as PTO, and after PTO is granted, the turbine can legally begin exporting power to the grid. This structured process helps ensure that both safety and reliability is there for everyone. So looking at the benefits that the clients receive after interconnection process is completed, first and most importantly, they gain legal permission to connect and operate their wind system. This ensures that there are no violations of utility requirements or state energy laws. Secondly, following these standards protects customers from any arbitrary or unconstitutional utility requirements because the rules are clearly defined in the state statute and in NV Energy's tariff. Third, interconnection ensures safe, compliant, parallel operation with the grid so the system can function reliably without causing power quality or safety issues, or decreasing power quality. And finally, an approved metering setup allows the utility to accurately measure both energy generated and energy consumed, which enables net metering or export crediting. These credits are defined under the NRS 704.775 and reflected in NV Energy's tariffs. Overall, this creates financial value for the customer and supports the economics of the project. Some important limitations and considerations that clients should be aware of is, firstly, the system must be 1 megawatt or less. Systems above that size are subject to a different regulatory framework. Secondly, depending on the size and location of the system, NV Energy may require additional grid upgrades or advanced metering, especially if the project is large enough to impact the local feeder. Third, if the system doesn't meet safety or technical standards, whether it's wiring, protection equipment, or code compliance, the utility has the right to reject the application until the issues are fixed. And finally, while interconnection handles the utility side, the project still must comply with local building codes, zoning rules, and permit requirements. These are separate from utility approval and must be completed for the project to move forward.
As mentioned earlier, the interconnection standards give us the technical permission to connect to the grid, but the financial reason we want to connect is net metering. specifically under Rider NMR-405. This policy, established by Nevada Legislature's Renewable Energy Bill of Rights, is the mechanism that ensures when our wind turbine produces more power than we're using, like on a windy night when the business is closed, so that energy isn't lost. Instead of wasting that electricity, Nevada Energy must take that power and give us a bill credit for it. Essentially, this policy allows the utility grid to function as a giant free battery for your business. You export power when you have too much and draw it back in when the wind stops blowing, ensuring you monetize every single kilowatt hour your turbine produces. It's important to understand exactly how those credits are calculated so you can accurately project your savings. Nevada operates on a tiered system where the credit value changes based on how much renewable energy is already online in the state. We are currently in Tier 4, which means that for every kilowatt hour of excess wind energy we send to the grid, we receive a credit worth 75% of the retail price. You might wonder why it isn't a full 100% swap. This slightly lower rate is the compromise for grid maintenance fees, but the major upside here is stability. By filing for the program now, we lock in this Tier 4 rate structure for 20 years. This protects your investment from future regulatory changes or rate drops, providing a guaranteed revenue stream that your accounting team can rely on for the next 2 decades. The real power of this policy is the unique rollover provision found in Nevada's net metering laws. If we have a very windy March, we might generate way more power than the facility can use, and instead of using those credits expiring at the end of the month, they roll over to April, May, and June indefinitely. This allows us to use our wind turbine like a savings account, banking cheap wind energy in the spring to pay for expensive air conditioning in the summer. Furthermore, because this is a statutory right, you aren't just a passive utility customer anymore. You are an active participant in the energy market, with a hedge against future inflation. This turns the variable weather of Nevada from a challenge into a reliable financial asset for your bottom line.
Now, I want to highlight the USDA's Rural Energy for America program, commonly known as REAP. This is one of the major incentive mechanisms available to rural businesses and agricultural producers who want to install renewable energy systems like small wind turbines. REAP provides grants, direct loans, and loan guarantees that help cover the cost of renewable energy projects. These incentives significantly reduce the upfront and long-term financial burden for clients. It is important to note that as of November 2025, REAP is undergoing some administrative changes and delays. However, guaranteed loans are still active, and for the fiscal year 2025, the program is offering up 80% coverage guaranteed for eligible projects. That makes financing more accessible and reduces the risk for lenders. Now, you might ask, why is REAP such a valuable tool for a small wind project? First, it provides financial relief by lowering upfront costs through low-interest USDA-backed loans. These loans can stretch out the investment and make the project much more affordable for rural businesses. Second, by reducing project costs and financing expenses, REAP helps shorten the payback period, making the systems economically competitive with the other forms of energy. Third, it encourages investment in clean, on-site renewable energy that protects the businesses from long-term energy price increases and reduces operating expenses. In short, REAP is one of the most powerful tools available to rural businesses looking to install small wind systems. It directly supports the economic feasibility of their project and improves the long-term financial outlook for clients.
My name is Trent Naclerio, and I'll be covering the Nevada Portfolio Energy Credits as well as going over the conclusion. Our final incentive are the Nevada Portfolio Energy Credits. Under Nevada's Renewable Energy Portfolio Standard, owners of renewable energy sources can gain Portfolio Energy Credits, or PECs, at a rate of 1 credit per kilowatt hour generated, with some additional stipulations. The only relevant stipulation to the 1 credit per kilowatt hour generated rule for this project specifically is that if the renewable energy source is maintained by the customer, a value of 0.05 credits is added to each credit earned. This means that for every kilowatt hour generated, the owner will receive 1.05 credits. As a note, renewable energy sources that utilized a financial incentive directly from the state of Nevada in their construction are not in ownership of PECs generated from that source and therefore cannot be traded. Now I'll be talking about what this actually means for the investor. Nevada's renewable energy portfolio has a highly accelerated schedule in comparison to other U.S. states. By 2024 and continuing through 2026, at least 34% of Nevada's utility energy must come from renewable sources. This standard is up to 42% by 2027 and eventually has to reach 50% by 2030. This is important because Nevada PECs are bought by utility companies in order to reach these portfolio standards that they must meet. There is no fixed value for the PECs, meaning as the portfolio standards get stricter, the price of the PECs rises. PECs can be earned at the same time as net metering is being run, allowing multiple sources of production-based value from one source of power. Now I'm going to give a brief summary of the different policies and incentives that we outlined in this project and their benefits. Our policies that we used were the Nevada Interconnection Standards and Nevada's net metering policy. These allow for the legal addition of the renewable energy source to Nevada's electrical grid, and it uses this connection to secure additional value in the form of credits, allowing for extra production of electricity to be valuable in the future. This is especially helpful for this project, as due to the remote location and varying amounts of time and electricity usage, there will be many instances of excess power generation, in the case of few customers, and instances where more electricity is needed than can be produced locally, a lot of customers arriving at once. Our incentives that we used were REAP, or the Rural Energy for America Program loan system, and Nevada's Portfolio Energy Credits. The REAP program helps fund the project initially, lowering the amount of cash on hand needed to start construction and lowering the interest rates for the loan. Nevada's Portfolio Energy Credits provide an additional and low-effort stream of income for the project, reducing the payoff period significantly, and they grow in value over time. To conclude, the policies and incentives used in our proposal for the installation of this project make the investment much less risky. Business in a remote location can sometimes lead to lower revenue, but offputting those costs through a lower initial investment, lower ongoing costs for maintenance and operation, and a separate stream of income unrelated to customers ensures that this project has a much easier path to recouping its cost and eventually turning a profit. We hope that this presentation was helpful for you, and thank you for considering our proposal and for your time.